So I recently returned from the Association of Classical Christian Schools conference in Atlanta, and one thing you notice at conferences of classical education is that there's a strong desire to teach by story in classical education. I teach science, and I think sometimes when people want to teach by story in science, they imagine they need to be sharing like the biography of Isaac Newton or the story of the discovery of the X-ray and things like that. And don't get me wrong, those may be great things to do. And in fact, Isaac Newton's biography fascinates me in a way because he spent so much of his time on stuff like theology or being warden of the Royal Mint, stuff that he's not really remembered for today. But to him, it was very important work. He spent years, lots of time on this stuff. And you think sometimes, we are probably not as smart as Isaac Newton. And Newton spent all his time on this stuff that, a lot of people today would kind of say, maybe not that important, maybe a mistake. And how might we be spending our own time poorly as well if Isaac Newton spent some of his time poorly, if you think that. Anywho, but my big point here is, even if you're not doing that stuff, if you're teaching science well at all, you are teaching a story, because science is a story. And how do you know it's a story? Well, it's a story in part because the order in which you read stuff matters, right? You can't read a novel by reading chapter 14, then chapter 1, then chapter 16, then chapter 3, and so on like that. It wouldn't make any sense, right? If you try and read a science textbook that way as well, you're going to be similarly confused, right? You have to take in the story, and so the order in which you read this stuff matters. So I am personally mainly a physicist, but I teach some other science classes as well, and so this fall I'm teaching a course on chemistry, so I started making my notes for the fall. And it's very clear, I know this might seem obvious, but it's very clear making my chemistry notes for fall that the book of physics is the prelude to the book of chemistry, right? You try and read the book of chemistry without reading the book of physics first, it's not going to make any sense, okay? Or you're going to need someone else to explain to you, like the parts of the movie you were asleep for, okay? It's not going to make sense. The start of the textbook, the chemistry textbook we're using, actually starts off with a combustion story, and just to make this clear that it is a story, I can tell you the combustion story. So it goes something like, once upon a time, there was a room filled with hydrogen molecules and oxygen molecules bouncing around, minding their own business. Then into this room we introduced flame. And the flame gave these molecules more energy. So they're moving faster now. They're bumping into each other fast enough that chemical bonds are actually broken. And so now for an instant, instead of having hydrogen molecules and oxygen molecules in the room, we have sort of naked, unbound, if you will, hydrogen atoms and oxygen atoms floating about. Okay? But those hydrogen atoms and oxygen atoms, unbound, attract each other. And so they rush together into a lower energy state, and that lower energy state is water. So this reaction produces water as its product. But water is a lower energy state. You can't just have energy disappear from the universe. And so where does it go? In this reaction, well, if you've ever seen it done, into a boom and a flash and heat. That's where the energy goes. Okay? So that makes a nice little story. And at the end of it, you'll notice I invoked part of the story of physics, right? I invoked the principle of the conservation of energy, which we learn from the book of physics, right? The missing energy can't just disappear. We learned that from the book of physics. So where does it go? Into a boom and a flash and heat. So that's just an example there that science is a story.